Indeed, jamming is the best way to start your day. And I've got to say, we've got a really great group of people who present the show at the moment. You're joining It's Thursday Drive. I'm joined in the studio by Dr. Kat, who many listeners will know from Boiling Point. She's been a regular co-host on that show for the last couple of years. And we just spoke to the chief scientist at the Australian Museum. I'd like to say we're going to speak to someone now who's starting out their research career. Ben Ferguson is a PhD candidate and he is researching tissue engineering. Hi, Ben. Thanks for joining us.
Thanks for having me on the program.
It is an absolute pleasure to have you here. Now, I'm not a scientist. I love doing this show because I get to speak to people from such a broad range of backgrounds and a broad range of specialisations. But can you explain to me what on earth tissue engineering is?
So tissue engineering is an emerging field that sort of blends engineering with medical science. And what we're sort of aiming to do is to find ways to repair or replace or improve parts of the human body. And we usually do this through such type of therapies as cellular therapies or implantable 3D-printed medical devices. And we can also use drug therapy and types of mechanical stimulation. So it's sort of like, it's quite a multidisciplinary field. It sort of blends engineers with clinicians and biologists and also mathematicians and computer professionals. So yeah, it's a great field to be in, and yeah.
So you started off as an engineer.
I did, yeah. So I studied biomedical engineering and economics at the University of Sydney, and that was a fairly new course back when I was starting, and it's just been growing and growing ever since.
Wow, that sounds really interesting. So when you talk about, replacing, it's almost like, it sounds like something out of science fiction, doesn't it? Replacing body parts with 3D printed, components.
Material, no, definitely. It's sort of, right now, it's sort of, it's still sort of in its research and development phase and slowly sort of moving into, transitioning into into the clinic. But you take, for example, someone who's to talk about my own research, you take someone that's lost a large section of their bone tissue. So, for example, someone's jawbone. It's a vital part of their body. It's responsible for how they eat, how they breathe, how they speak, and how they look as well. If they've sort of experienced some type of oral cancer that needs to be cut out, or they've had a major car accident, or they've had a self-inflicted gunshot wound, what can happen is if a large section of the bone tissue has been lost, it's not going to be able to heal without some type of intervention. It's not like just a sort of basic fracture where you can put a cast over it and the bone will eventually grow back together. What happens is if a large section is lost, you need some type of bone substitute. And what we're working on is a type of 3D printed bone graft that will you can put it into a large section of into a large void in the bone, and the bone will eventually start to grow through that structure and regenerate the defect.
Hey Ben, this is Kat. Hi. So that sounds really cool. What kind of material is that you use for the 3D printing?
Sorry, Kat, can you repeat that again?
Yeah, sure. What kind of material is that you use for the 3D printing?
So it's a type of bioceramic. Usually what's happened in the past is we'll use sort of a metal or where they've even taken animal transplants or human transplants and tried to put that into a large void. What we're looking at is a novel type of bioceramic that's similar to the structure of bone itself, but it's also doped with certain types of trace elements that will elicit a better biological response in the bone tissue. Because in the end, that's sort of a large part of tissue engineering is trying to sort of develop materials that are acceptable to the human body, and we call that biocompatibility. It's sort of trying to develop these materials and the structures of these materials so that it's accepted by the body. And what that's going to do is that's going to allow for a better recovery overall.
Does that mean when you implant that tissue substitute into the person's body, does that stay in the body, or does that get kind of broken down after a while?
So what's good about this type of bioceramic is that it's going to actually dissolve over time. Say if we'd had like a type of metal, that's going to stay in the body forever. And the body doesn't necessarily accept that entirely. Whereas with this type of bioceramic, what's going to happen is that the bone's going to grow through the structure, and the whole thing is that the structure has a lot of holes in it, and we call that, it's a porous structure, and because it has all these holes, it's going to allow space for the bone to grow through.
That is
what's going to happen over.
Ben, sorry to interrupt you. That is really cool. That reminds me of the when you replant or regrow coral reefs. It sounds very similar. Like you kind of plant those. It might even be ceramic. I'm not sure. I think you can use different materials, and then you plant pieces of coral on it, and they kind of grow their way through those through the platform they get to grow. I'm sure it's a very different process, but it just reminded me. So it's very cool.
Oh, definitely, yeah. I think it's the structure of coral was calcium carbonate, if I'm not mistaken.
Yes, that's correct.
And I know that there was a type of therapy where they would crush it up and they'd be able to compact it into a certain into a sort of a void in the bone. I know in my experience with dental implant technology, when sort of a tooth is ripped out, and they want to be able to put a dental implant into the jawbone, they need sort of a sufficient foundation to put the implant in. And I know they would use those ground up coral granules to put into the hole.
Oh wow! So it wasn't too far off. That's really cool. So Ben, are you actually specialized in a certain type of tissue?
In a certain type of tissue?
Yeah, that's right.
Yeah. So I'm mostly specialised in bone tissue, and what I'm looking at is I'm sort of on the computational side of things. So I'm looking at how we can rapidly prototype these types of systems, so that they're tailored to each individual patient that you put it into to each individual patient. So everyone sort of comes in different shapes and sizes, and also the injuries that they experience, they're also very different. And so what that means is that when we're trying to design these systems or these devices, you don't want a one-size-fits-all solution. You want to have, something that's going to be perfectly tailored to your experience and your defect and your anatomy. So we're sort of what I'm looking at is how we can rapidly prototype these devices, and then ideally what would happen is a patient would come into the clinic. We'd take a CT scan of their injury or defect, and then later that afternoon we'd have that all 3D printed and implanted into them. That's sort of what we're working towards, but it's definitely the dream.
Yeah, that is really fascinating. So a quick last question. You mentioned earlier that it is in the transitioning process to the clinical stage. So has a human person ever received such a transplant yet?
So we're looking at sort of the evolution of moving from research all the way to into putting these medical devices into people's bodies. It involves quite a lengthy sort of process of making sure that it's going to be safe and so forth. So we're looking sort of at the modelling and we're just completed the first clinical trial as well.
Yeah, awesome. Yeah, cool. Thanks so much for telling us about your research. That's impressive.
No
It really does sound like science fiction. Absolutely incredible. Thank you so much for joining us, Ben.
No worries. Is it possible? This is a jazz
Yes, it is.
radio station, if I'm correct.
Yes, it is.
And you've asked me to talk about biomedical engineering.
Yes.
Is it possible if I could finish off with a quick joke that I think sort of brings these two together?
You go for it.
So, jazz drummers, they're known for always being able to keep a beat. They can really, 80 beats per minute, they'll hold it there for, the entire song, for the entire way through. 60 beats per minute, whatever it is. They're the best in the world, these jazz drummers. So there's this famous jazz drummer, and he's doing this song, 60 beats per minute, perfect, and he's going through, and then right at the end of the song, he just stops and collapses, and everyone goes, "What happened?" And it's because his heart couldn't keep a beat.
Nice.
Thanks
So
very
they ended up rushing him off to hospital, and the cardiologist, he ends up falling in love with the cardiologist there, because she's operating on him, and it's all good. And then in the end, his heart skipped a beat. The jazz drummer.
Yeah.
Anyway.
Thanks very much, Ben. We got to go now. Sorry, because we've got another guest to squeeze in before the end of the show. But thank you very much for joining us on Eastside Radio.
Thanks so much, guys.
Thanks.
Talk to you later.
Bye. And that was Ben Ferguson, who's